Cookie, raise your hand, please.
Oh, wait, if we have any questions.
Abby. Elias, you haven't watched any videos?
No.
What's your plan on taking my test? Because didn't you miss my test too?
Yeah.
She's just gonna cry and respond. Because it's quite right.
I saw a pretty bad quiz or whatever too.
Oh my, he's really behind. Sweetie.
You probably should have stayed here instead of going to that thing. Did you go to that thing yesterday?
Yeah.
You probably should have stayed here.
I didn't realize it actually worked, so I didn't know I was going until literally that point. Let's go.
Is that for me? He doesn't know
Where are you going?
We didn't expect it.
All right, what'd you ask for? Number 10. I'm gonna do it over here. All right, raise your hand if you can get me started on number 10, please. All right, go ahead, Zach.
U equals x plus 4. Du equals dx.
Okay.
Hello.
You like it?
You got any more? Or you need a lifeline.
I need a Coach White.
All right.
So, we're supposed to find 2x plus 1. We're supposed to use that, the u equals x plus 4. So I did 2u minus 7 equals 2x plus 1.
Woo! You worked hard.
Is it, there's some other way? There is?
You're probably gonna be right, but you worked hard.
Okay.
What's the easier way of doing it?
Did you?
I don't know. What?
What?
You just put your Yeah, I
I
got
think mine was
that.
pretty easy though.
Well, I think you're gonna get it right. Because that's gonna be minus 8 and then plus 1.
Yeah.
So wait, pause.
Skip this step.
How did you do 2u minus 4 plus 1?
Because x is equal to u minus 4. So I put u minus 4 where the x is. And 2 times x. U minus 4 instead of the x.
That makes so much more sense. That makes sense.
So then we just separate it. So we do this over this, which is that, and then this over this. And then from there, it should be pretty stinking straightforward. So this will be 3/2, 2/3 times 2, 4/3. This will be 1/2. So 2 times 7, 14. Don't forget about the C, and don't forget to plug the x plus 4 back in. Did you get the right answer though, Ethan?
Yes.
Very nice.
I'm confused on the to be used for
Confused where? Here?
Yes.
Take this over this, which gives me this.
Oh. Right.
Okay.
They're down there on that printer in my work area.
In your work area? Okay. Thank you. Sorry.
All right, raise your hand. Any other questions on this before we move? MK?
Plus 8. Plus 8. Sorry, I'm already plus 2, but number 8. Okay. Oh, sorry.
Number 8.
Yeah. No, I know 7. And I know. No, I don't know 6, but I know 7.
All right, raise your hand. Somebody else that can help me on number 8. Jennifer? U equals 4x. So du equals 4 dx. All right, Jennifer, what does my integral look like?
Oh, yeah. Oh, wait, never mind. It's 1/4
Very good. Because we have to, I think what you're getting ready to say is we need to do that. Okay, when I integrate sine, I get cosine, positive or negative. Why is it negative?
Starts with a C.
Starts with a C. So we end up with negative 1/4 cosine of 4x plus C.
Oh, I thought I didn't know what to do with my sign. Like I thought you needed something for that. Like
You forgot you could integrate it? Is that what you mean?
no, like I mean I thought you had like substitute something in for sign.
No.
That's why I was lost.
Abby?
Number 6.
Was that fun? Was it that much fun?
Actually, it wasn't good.
It was
It was bad.
All right, number 6. Somebody else. Somebody else. Ed, mate, help me out on 6.
So u equals 1 minus x. Du equals negative dx. So we solve for x squared. So x equals 1 minus u, and x squared equals 1 minus u squared.
You mean x squared
Yeah.
equals that?
Yeah. So your integral is negative sum of 1 minus u squared times square root of u du.
And let me stop there. All right, any questions getting this far?
Yeah.
Yeah.
Which question, Mallory?
Well, like I just kind of plugged in the 1 minus u into x, so that whole thing's squared.
Right, that's the same thing as that, right?
So do you have to work it out like that? Like
Do I have to show this step right here?
no, I mean like do you have to like
Do you have to multiply it out?
Yeah.
Yes.
why?
Because if you don't do that, you can't multiply this in.
Okay.
Any other questions before we move on? Abby M?
Where'd the negative come from? Or is that a negative on that side?
Right here.
Oh, okay.
Wait, so when, like, did you plug that into x squared?
Say it again.
Did you plug that into x squared?
I plugged that in the x squared. I went ahead and multiplied it when I did it.
So wait, why did you get? Okay, never mind.
All right, so then we need to multiply that in. So this is the same thing as u to the 1/2. So I have u to the 1/2 minus 2u to the 3/2 plus u to the 5/2. Okay. So this is going to be 3/2, 2/3. This is going to be 5/2. So I multiply by 2/5, which gives me 4/5, and this is going to be 7/2, 2/7 plus C. And then I'm not going to take the time, but make sure we plug in 1 minus x in there. All right, I'll do one more before we move on to today's.
I don't think we have time today, Coach.
Huh?
I don't think we have time.
We've got time, Zach. Which one? 7. I'm wanting you guys to pass this thing, so we have to take advantage of every day that we're in here. Zach. All right, 7. Elijah, you picking it up?
I think so.
All right, what do you got? Help me on 7.
So u is x plus 1. So du is 1 dx. So x is u minus 1. So is it just square root of x?
You.
U, that one, yeah.
And let's go ahead. Let's go ahead and change it
Oh,
to.
it's a cube root. Oh,
the
sorry,
one
I
there.
can't see.
All right, distribute. So u to the 1/3 times u.
4/3.
All right. So u to the 7/3, 3/7, u to the 4/3, 3/4, plus c. Make sure you plug back in. Do you guys notice how to go up by 1? What's the easy way to go up by 1 when you go up by 1?
Another number.
Yeah, add these two together, and that gives you your new numerator. That's the easy way to do it.
Oh,
Add these two together, and that gives you your new numerator.
so this is 4 bits. It would be 9.
9/5.
That is crazy. Why no one told me that before?
I just did.
Okay, before you know why?
All right. So we integrated indefinite integrals on Monday.
What was the
Indefinite composite integrals. There's 3 sheets. Today we're going to integrate definite composite.
X was 13, I'm going with D. Your number.
I will look at it this second. What?
Oh, the word she's over.
Yeah, TCU.
I don't know. You just did it.
I feel like this you stuff.
It was
That's all there is.
even more.
Work last night?
Yeah, late.
No. I can tell.
Oh, all three of you.
Oh, we got more.
I was
Madison.
So we got less money than nothing.
Well, my mom made a paper.
Hey, you know what that it's not, I did not say this.
Yeah, I
If you pull that chill.
It's called budget cut.
Where'd you get that kit from? I don't know.
I had
All right, here we go. All right, number 1. Need your attention. Number 1, we're going to integrate from 0 to 1, x times x squared plus 1 to the 3rd dx. So, Abby, what do we do?
Me or?
Abby M.
Okay, well, do you just find u first?
All right.
It's x squared plus 1. And then du is 2x dx.
Okay, so I need to
5 and 2.
do that. And we end up with a 1/2 and that, correct?
Yes.
All right, now, does anybody want to put up 0 and 1 right here? Because we can't. Somebody tell me why we can't put 0 and 1 right here.
Because this is like what we did yesterday, so you have to, until you like get back to the x's, you can, like, because it's indefinite, until you get back to the x's.
You're kind of on the right track. At this point, there's 2 different ways you can do the problem, and I'll show you both different ways, or both ways. Ethan, what do you got?
Is it because there's like you can't plug in those values yet? Because
Well,
we're
what-
dealing with u.
Right. What type of values are these?
Those are x.
These are x values. What is this dealing with? U. So what values need to be here? U values. So raise your hand if you can tell me what this bottom U value needs to be.
I can't tell you this right now.
All right, what do you got, Zach?
I don't know right now. Because could you do like
Just spit it out.
Could you plug in, like, use the Butterfly theorem and calculus and plug in it right there to you?
No. Marshawn? Bottom one is 1. What's the top one? 2.
Don't you just plug it in?
That's all you got to do. Take your x values, plug it in for x right here. That produces u values. Then put your u values in. Okay? All right. Great question. Everybody hear Abby's question?
Yes.
So you want to know, well, if I do that, do I have to change it back to x? Answer is no. So if you change these to u, then you're done with x. And everything, the rest of the problem's in u.
That's because we don't plug it in.
You do not. You're done with the x's.
What about whenever you have to do, like, change that problem around? Like, you say you have to, like, change it to x squared equals u, or
Doesn't matter.
you always plug into the first one.
We're always going to plug in here, and that's always going to give me the u's. All right, so that is u to the fourth, excuse me, over 4, 1 to 2. I'm going to make that 1/8. Ethan?
When you said that we're done with the x's, you mean that we don't substitute x squared plus we don't do it all?
If you change the limits, then you're done with x's.
Okay.
You're done with x's for the problem.
Is there ever a chance we don't change
So we
it?
never go back to X now?
You do not go back to x.
Was there ever a time that we don't change it?
Well, there's 2 different ways you can do it, and I'm going to show you.
I could never go back.
But changing the limits is probably the best way to go.
Okay.
Alright, cool.
All right. So that's going to be 16 minus 1. So we end up with 15 over 8. Raise your hand if you can tell me what 15 over 8 is. What does 15 over 8 represent, Abby?
Is it the area under the curve?
Or
Or
changing the function above. Very good. Okay. Now, here's the other option. This is probably the best way to go. The other option is you do this and you don't put any limits up. Okay? And then you integrate. And then you plug back in. And then you put the original limits back. And then you plug in.
All right. So first one.
But I want to show you that you end up with the same answer. So if I plug in 1, or you should, unless I did something wrong. I plug in 1, and that gives me 2. I plug in 0, and that gives me 1. Oh, I'm forgetting that. That was the difference. Okay, and as you see, same thing I had there. Okay, but this right here, probably the best way to go. Got it?
Got it.
Alright, let's find another one.
This is our sign up for the day too.
Yes. We'll do a trig one since you guys don't like trig. Let's look at number 4. I love trig though.
Did we do a lot of trig last year? And pick out.
What?
Did we do a lot of trig last year?
I think over half the year was trig.
That's what I thought. That's why I don't like it.
Alright, somebody new? Hunter, get me going.
Okay, so let's see. So the U, you find U, and it would be X. Right.
Alright, u is never going to be just x. U can never be x, because if you're doing u for x, you're not gaining any ground. Don't talk. I'm talking to Hunter right now. Let's see if he can come up. Remember, what do we want the u to be?
Could be, would it be X cubed?
U needs to be inside of something. So what is something up there that's inside of something besides x? I'll give you a hint. I'll give you a hint. How else can I write that right there?
Like sine X cubed? Is
I
that
can do sine and then cube. So there's your hint.
So sine X?
Sine of x is my u. Good.
Okay.
All right, derivative of sine? Cosine. All right, John Ryan, what's my new integral?
U cubed is the
u cubed du. All right, what are my limits? This one takes a little bit more thought.
Sine pi over 6 is 1/2.
Sine of pi over 6 is 1/2. Perfect.
And then sine pi over 2 is
Make me proud.
1.
1. Very nice. Nicely done. Again, you're plugging in the pi over 6 here, so sine of pi over 6 is 1/2. You plug in the pi over 2, sine of pi over 2 is 1. If you don't know those, you should. Integrate u. Integrate u gives me u to the 4th over 4.
U and 4 look way too similar.
Say it again.
U and 4 look way too similar.
Mine always look like that too.
We gotta do some different.
Made it whole.
I plug in the 1, I plug in the 1/2. So that's going to be what, 1/16? So that makes 15/16, which makes 15/64.
1561?
64.
If that one doesn't have.
It's actually Chuck 6.
All right, let's do 10 while we're talking about trig.
What?
10 is the integral from 0 to pi over 6 of secant of 2x times tangent of 2x dx. All right, Leilani, what do you got? What's u? 2x. All right, Courtney, what's my new interval?
I don't know. Early.
Well, we made u 2x, so that means everywhere I see a 2x, I should be putting u. So I'm going to have secant u, tangent u, du. I've got to put the 1/2 out here, so now it's a matter of getting my new limits. And getting those new limits should be pretty easy. Patty?
The bottom is 0 and the top is pi over 8.
Questions on those limits? Again, all we did was take 0, plug it in here. 2 times 0 is 0. We took pi over 6, plugged it in here. 2 times pi over 6 gives me pi over 3. Okay? So that means we should be able to integrate secant tangent. When we integrate secant tangent, we get secant.
Would you not do secant of pi over 3 times tangent of pi over 3 to get your top one?
No. Remember, these are x values. We want to turn them into u values. So we always plug our x values in over here in our u
So it
equation.
doesn't matter that it's inside of that?
Does not matter. No. All right. So 1/2 secant pi over 3 minus secant of 0. And who's going to show me they know their stuff and can tell me what those two are equal to? Right?
Secant pi over 6 is 2. And secant 0.
You got it.
Very good. If you don't know them, you need to know them. That's on you. I can't help you on memorizing.
So why don't you change it again?
Say it again.
Why don't you change it? We could say that way.
I integrated. When I integrate this, it turns into this.
Oh, my bad. That's fine.
Alright.
Wait,
So,
is secant of 0 is because the, or whatever is the reciprocal, I don't know the word, like opposite cosine.
it's a reciprocal cosine.
So if the cosine of 0 is 1, that's why.
Cosine of pi over 3 is 1/2, so the reciprocal of 1/2 gives me 2. Alright. On 14 to 16, it says, given that f of x is an even function and that 0 to 2 of f of x dx equals 8/3, we want to find these three right here. So I need somebody to remind us what it means to be an even function.
I don't remember what.
Is it because we're two people?
What?
I have no idea.
Wait, this
Is it
is
when it's like mirrored?
very good, Courtney. What do you mean by mirrored? Give me a little bit more. Mirrored across what?
Isn't it the y-axis?
Perfect. Very good, Courtney.
Courtney.
An even function means whatever's on the right side is also on the left side. Good, Courtney. Okay? So now, what does that do to me if I'm wanting to find an integral, say, from -3 to 3? What do I know about what? It gives me a shortcut. How does it give me a shortcut? Right. If I do 0 to 3, and then I want the whole thing, all I have to do to the 0 to 3 piece is what? Double it. And then that gives me the other side. Okay? So we want to use that fact and what they gave me to work 14, 15, and 16. All right. So 0 to 2 is 8/3. What's -2 to 0 going to be?
8/3.
8/3. Hunter, why is it 8/3?
Because it's even on both sides.
It's the same amount on both sides. So whatever it is from 0 to 2, it's also on the other side.
So is there ever be a way that next makes it negative? That like when you look at it, it's an even function?
Not on even. Even, whatever's on the right is also on the left. Whatever's on the left is also on the right.
Okay.
So
So
for
it's the odd
15, it
order.
would be 8/3 times 2.
8/3 times 2. That one's 16/3. Okay, and then the last one.
3 times 8.
3 times 8/3, so we end up with 8. Very good. Okay, so if you got an even function and you have 1/2, you automatically have the other half. Everybody with me on that? Yes.
So what's an odd?
So what's an odd function? Courtney, you got that in your bag of tricks too?
Isn't it where like it's the I don't know, I can like draw it.
All right, come draw it.
Wait, no.
Watch out for. Oh.
Sorry, I almost knocked that over. I'm not gonna
Let's go. Come on, show off.
No,
This is your time to shine.
I don't know.
It's your time to shine,
I don't know
Courtney.
for sure. Okay, wait. So if it's like just an example like that, then isn't it mirrored on the X or no?
No.
It's like that?
Yep.
Okay, cool. Like that? Oh, I guess the line isn't a good example.
It's not a great example. It's not a great example, but it is an example. So give me
Okay.
one. Give me one that's a better one.
Like that? So then it'd be like that, right?
Perfect.
Okay. That makes sense.
So it would be turned to negative 1.
So that means if I know the area on the right side, what do I know about the area on the left side? They're opposite. Okay? So when you're dealing with an odd function and you know half of it, then you know the other half is opposite of what you got. So if 1/2 is negative and the other half is that same thing but positive.
So
Got
what-
it?
So what if it's like, will they ever ask an odd function but give you, let's say, 0 to -3?
It could.
So then how would you do that to end up the same distance? Because it'll be 0 to 2.
Are you talking specifically to this problem?
Yeah.
No, they can only give you something that's 2.
So how would they work?
0 to 2 or -2 to 0.
Okay.
Or -2 to 2. That's all they're going to ask you about. Abby?
So since one side is positive and the other side is negative, it's from all the way on this side to all the way on this side is 0.
That's correct. Everybody hear Abby?
I had a kid out here.
Alright, so they're telling me 0 to 2 is 8/3, so what does that mean -2 to 0 is? -8/3. -3/8.
She just said to flip it. Like it's exact opposite.
No, I said opposite. Opposite is signs. Flip it is reciprocal.
Gotcha.
All right. So then, as Abby said, 18 is 0. All right. And then that one's going to be,
I didn't really hear them.
because if I have a positive area here and I have a negative area here and they're the same amount, they're going to cancel each other out. Okay. And then this one's going to be, right, 3 times negative 8/3, so I get negative 8. All right. Any final questions? Main thing you need to remember to do when you're doing integrals of composite functions and they're definite, what do you have to do? What's one thing you can't forget to do? What did you say, Ryan? Change your limits. Don't forget to change your limits. That's where people usually mess up, is they forget to change your limits. So when you're doing definite integrals of composite functions, make sure you change your limits. Got it? Everything else is the same as what we did on Monday. All right, good job.